Hello class! Welcome to the lesson of New Energy Vehicle Motor and Control System Maintenance. Today we will learn about the common classifications of electric motors used in electric vehicles. Electric motors in electric vehicles are mainly used as motors, in addition to their power generation function. Let's take the electric motor as an example to do a simple classification. Electric motors can be divided into DC motors and AC motors, according to the type of power supply. DC motors are rotating motors that output or input DC electric energy. They can convert DC electric energy and mechanical energy to each other. AC motors are rotating motors that output or input AC electric energy. They can convert AC electric energy and mechanical energy to each other. DC motors can be divided into brushless DC motors and brushed DC motors according to their structure and working principles. They can also be divided into permanent magnet DC motors and electromagnetic DC motors. Electromagnetic DC motors can be further divided into series excited, shunt excited, separate excited, compound excited DC motors according to the excitation method. AC motors can be divided into single-phase motors and three-phase motors according to the type of power supply. Among them, three-phase motors are commonly used in new energy vehicles. AC motors can be further divided into asynchronous motors and synchronous motors according to their structure and operation principles. Asynchronous motors, also known as induction motors, have their rotor placed in a rotating magnetic field and obtain a rotating torque under the action of the rotating magnetic field. Therefore, the rotor of the motor usually has a squirrel cage shape. Synchronous motors refer to motors in which the rotor speed is synchronized with the rotating magnetic field of the stator. The rotor of the synchronous motor is a permanent magnet, and the N pole and S pole of the rotor magnet rotate as the rotating magnetic field of the stator windings moves. Motors can be divided into drive motors and control motors according to their applications. Our lesson focuses on drive motors. Finally, there are special motors such as switched reluctance motors and hub motors. After introducing so many types of motors, which one is more suitable for new energy vehicles? Let's take a look at this table. It is not difficult to find that in terms of energy conversion efficiency, torque speed performance, and power density, AC induction motors and permanent magnet synchronous motors have advantages. Currently, the most common used motors in electric vehicles are AC induction motors and permanent magnet synchronous motors, but DC motors and switched reluctance motors also have certain competitive advantages. Next, let's take common new energy vehicles as examples to briefly introduce the types of drive motors they use. First, let's take a look at Tesla's new energy vehicles. The drive motor they use is a three-phase asynchronous motor developed independently, which has the optimal winding linearity, greatly reducing resistance and energy loss. At the same time, the size of the motor is very small relative to the whole vehicle. Next, let's talk about the drive motors used in BYD and BAIC electric vehicles. They are water-cooled AC brushless permanent magnet synchronous motors. Finally, let's take a look at the Rowe E50 electric vehicle, which uses an AC synchronous motor and an oil-cooled cooling method for the motor assembly. This section introduces various types of motors used in electric vehicles. Of course, each type of motor has its own pros and cons. We will learn about the structure, principles, and characteristics of DC motors, AC motors, permanent magnet synchronous motors, switch reluctance motors, and hub motors through the lesson of new energy vehicle motor and control system maintenance. Currently, permanent magnet motors have attracted widespread attention and application due to their high efficiency, high power density, and high torque density. We will face many choices in our growth, and choosing correctly by weighing the pros and cons is the path we must strive to improve ourselves. That's all for today's lesson. Thanks for listening.